All right, so I think this will be our final video for the math semester. We had a little technical problem finishing, or with this problem in the last video, so we're going to finish it up here and then continue on till the end. So this particular problem asked me to create an equation for a line parallel to this given equation, y equals 2x plus 1, that goes through a certain point, 5, negative 3. So we decided if it's parallel, that means we can borrow the slope and use the same slope. The given point provides me an x and a y that I know will be true in my equation, but we had to solve for the b. So we're going to go ahead and finish this off. So the y here was negative 3. The slope that we determined we could use was 2. The x given to me is 5 plus b. So negative 3 equals 10 plus b. Subtract 10 from both sides, and b equals negative 13. Oops, well, I probably shouldn't circle that because that's not really the actual answer, but that's the last piece that we need. Right? We need the b and we need the m, and now we can write the equation. So y equals 2x minus 13. So that's my final answer. All right. Question D here asks me to write an equation for a line perpendicular to the given line y equals 1/2 x minus 3 that goes to the point 0,5. So for a perpendicular line, I know it's going to have the opposite reciprocal slope. So I'm just going to make a little note there. So the slope of the given line is 1/2. So my new line is going to have a slope of, instead of positive, negative, instead of 1/2, 2/1. This one goes through the point with an x of 0 and a y of 5, which, if I think about it, that actually tells me the y-intercept, but I'm going to go ahead and solve this the normal way, right? The b is what we don't know. So y, take these things and fill in my equation. Y equals mx plus b. The y is 5. The m is negative 2. The x is 0. B is what we need. So we plug in the things to the appropriate spot, and we get 5 equals negative 2 times 0 is 0, plus b. So b plus 0 is 5. So the 0 doesn't really do anything. B is 5. So now we know y equals negative 2x plus 5. Right? If I thought about, recognize early on here, right? If the x coordinate is 0, whatever the y is, that is the y-intercept. So that actually worked out pretty good. And then we're on to our last problem of our review here, Unit 4. This is actually just a scatter plot problem, similar to one we did in class, actually, where study time is being compared to the test percentage. So did you study more and get a better grade? So Mr. Hernandez's students love Integrated Math 1, as all students do. Susan wanted to know how long she should study if she wanted to get an A on the final exam. She collected study times and test scores for the last test. The results are below, so there's the table. And it asked me to scale and label the axes and make a scatter plot. And I actually did that before we started because it's not a very exciting video to just watch me fill that in or whatever. So maybe you already did that. If you need help, I'll leave that there for a second, or you can pause the video maybe and you can copy it down. So I made every 2 lines be on the x-axis, every 2 lines was 5 minutes, and on the y-axis every 2 lines was 10% on the grade. So I actually didn't end up taking up the whole thing, but it kind of worked nicely on my screen, so that's why I did it that way. So create the scatter plot, we did that. So I already did that part. According to the graphing software, right, so like Desmos maybe, if you punch those in, the line of best fit would actually be y equals 1/2 x plus 56. So graph the line within the scatter plot. So we're going to go ahead and do that down here. So we know 1/2 x plus 56. That means the y-intercept is 56. So here's 55, and we'll just go a shade above. And then the slope is 1/2, so up 1 over 2. Well, we want to be careful because we want to make sure, actually it would work okay for me to do that in this case the way I scaled it, but we don't want to just go up 1 box and over 2 boxes. It depends on what you scaled your thing as, your axes as. So we're going to go, instead of up 1 over 2, that's going to be really small and hard to see. Let's go up 10. So I'm going to go from 56 to 66, and then over 20. So up 10 over 20. So that would be somewhere in here, right? So my line of best fit, right? Really what I just did there was create my slope triangle, right? I created a slope triangle that went up 10 and over 20. And my line of best fit is going to be that and just keep on going. So I don't know how good that is by hand, but you can see kind of generally what it is. And keep in mind our test is multiple choice, so you're not going to have to draw a line of best fit. You're more likely going to have to interpret what it means, which is what these next questions ask me to do. Okay, so draw a line of best fit, we did that. And okay, so question C. Whoops, that followed me down here. Describe the association linear or nonlinear. Well, looks like it's going in a straight line to me, so that's linear. And positive or negative, and it's definitely got a positive slope, so it's a positive correlation, which means as the x variable goes up, which was studying, right? So as the studying went up, the y variable also went up. So as the studying went up, the grade went up. Part D, interpret the slope in terms of minutes and study time and test percentage. Minutes of study time and test percentage. So, right, our slope was 1 over 2, right, both positive. So that means let's do it this way. So it goes up 1 over 2. So it means it goes up 1 point for every 2 minutes of studying. Part E asked me to interpret the y-intercept in terms of minutes of study and test percentage. Well, I know that the y-intercept is at the point 0, 56. So that means if I study 0 minutes, I would expect to earn a 56% on the test. Right, so that's kind of what all of this information here tells me, right? On average for that class or that group of people that they collected the data, on average, if you don't study at all, you get a 56. And on average, you'd go up 1 point for every 2 minutes of studying, right? Some are above the line, some are below the line. So some did better or worse than predicted, but that's kind of the average. Okay, part F. According to the line of best fit, what grade would, oops, where am I? There we go. What grade would Susan earn if she studied for 1 hour? So, right, minutes of study. If she studied for an hour, that means my x is 60 minutes, right? So I'm going to take my equation. 1/2 x, which here is 60 plus 56. Half of 60 is 30. So if she studied for an hour, 60 minutes, you would expect to get an 86 on that test. So again, using our predictive model here a few more times, according to the line of best fit, what grade would Susan earn if she studied for 10 minutes? So really the exact same thing, except instead of 60 like the last one, this time our x is 10. So half of 10 is 5. So if she only studied 10 minutes, she could expect a 61. According to the line of best fit, how long would she need to study to get a 90, right? So this means, right, I have my same equation, but this time instead of giving me the x, it's asking me, to figure out what the x would have to be if my y that I want to get is a 90, right? So I'm going to go ahead and I'm going to replace the y with 90. And if I do that, I can I could eliminate the fractions, but we don't really need to. This one's pretty simple. If I subtract 56 from both sides, and I get 1/2 x equals 90 minus 56 is 34. So from there I can multiply both sides by 2, and the fractions cancel out. So I'd end up with x equals 68. So I should have to study 68 minutes to get a 90% on the final. Okay, part I. According to the line of best fit, calculate how long she would need to study to get a 100% on the final. So we're going to do the exact same thing, except this time instead of a 90, we're looking for 100%. So 100% and solve for the amount of time. So we're going to do the exact same thing. Subtract the 56. And we have 1/2 x equals, and now we have 44 on this side. So same thing, I could multiply both sides by 2. I could also just think, well, what does x have to be if half of x is 44, right? So x would have to be 88. Half of 88 is 44. So 88 minutes. And the very last part of our study guide here, it's been a pretty long journey to get here. Complete the table to calculate the residuals. The line of best fit is the same, y equals 1/2 x plus 56. So we actually, to figure out all these residuals, we have to figure out all the predictions first, right? So this is my x. These are all of my actual y's, and then these are my predicted y's, right? And remember, the residual is the actual minus the predicted. So we have to go through and figure out all these predicted y's. So let's go ahead and do that here, right? So I'm going to take my equation and I'm going to think of it like the function machine, right? I'm going to put in the x and I'm going to get out the predicted y. Okay, so for this first one, if I put in a 20, 1/2 of 20 is 10, plus 56 is 66. For this one, 26, I plug in 26 minutes of study time, half of 26 is 13, plus 56 is 69. 28 minutes of study time, I'm going to plug 28 into my function machine. Half of 28 is 14, plus 56 is 70. Right, and if I look at some of these, this went up, right? The change in y, I'm sorry, that's the change in x. Change in x is 2, and the change in y, right, predicted y, is 1. So 1/2, that was our slope. Okay, so we could kind of use that to figure these out, but we're going to keep using our formula. So plug in 32. Half of 32 is 16, plus 56 is 72, right? Again, it went up 4 minutes and 2 points. 38. Plug into 38. Half of 38 is 19. 56 plus 19 is 75. 43. So 43 is an odd number, so we're going to have a decimal here. Half of 43 is 21.5. Plus 56 is 77.5. 46 minutes of study time. Half of 46 is 23. Plus 56 would be 79. And finally, 53 minutes of study time. Half of 53 is 26.5, right? Plus 56, that would be 82.5. So we've made predictions, excuse me, we've made predictions for all of our study times, and then we want to see the residual, so the actual minus the predicted, right? So we're just going to do subtraction all the way across here. So my residual, 68 minus 6 is positive 2. Right? 71 minus 69 is positive 2. 67 minus 70 is negative 3. 69 minus 72 is negative 3. 77 minus 75 is positive 2. 70, is that 79? 79 minus 77.5 is 1 point positive 1.5. 81 minus 79 is positive 2. And 82 minus 82.5 is negative 0.5. So that's really what all that it asks you to do. If I think about what this means for a second, right? All of these ones that are positives, that means they did better than you would predict. And these guys that are negative, they did worse than you'd predict. And if I actually go look at all the residuals and add them up, right, that will add up to 0, right? Positive 2, positive 4, positive 6. There's 2 negative 3s for negative 6, so that balances out to 0. There's a positive 2. This should be negative, and negative 1.5, negative. So that's just kind of a bonus lesson for you, right? All the residuals add up to 0, right? That's why it's an average, because all together they average out. You know, the difference is 0. Anyway, so that's our final problem. Keep in mind that these problems are going to be multiple choice. So a lot of these things that we went through here are the steps you need to find the answer, but you're actually going to have some information available. You're going to have the answer in front of you. So in some cases, you'll be able to like work through them a little bit faster. But hopefully that helped, and we'll have a good result on the test.